So in section 11.7, we're going to solve exponential equations. And my question to you is, why do you think we'd call this an exponential equation? Why isn't it some other kind of equation? What about it do you think makes it an exponential equation? A little bit more. I mean, you're on the right track. What about the exponent? Yeah, you have a variable in the exponent. The unknown is in the exponent, so it's an exponential equation. Now, our idea behind solving that is going to be pretty simple. If you have two things that are equal, if x equals y, then the log of x equals the log of y. Now, the way I've written it, I'm assuming that you have base 10, but it doesn't necessarily have to apply to just base 10. It could be any base. So any value of b, as long as b is greater than 0 and different than 1, and you'll be fine. How does that help us out here? Well, we have two things that are equal. So let's take the log on both sides and see what happens. So if I take the log of 7 to the x, that should equal the log of 12. Well, now that looks even messier, right? It's like, well, ugh, yuck. But that actually does help us out. Think about your properties of logs. What's the power rule say we can do? Yes, that x can come out in front, right? So let's move that x out of the exponent and get x log of 7 equals a log of 12. Okay, that looks good. Almost done. I mean, we're just one step. X is being multiplied by log of 7, but I want x by itself. What's the opposite of multiplying by log of 7? Divide by log of 7. Good. So it's x equals the log of 12 divided by the log of 7. Yay. That's our answer. I'll tell you what. Let's check it. Let's check it on our calculators and get comfortable with doing these kinds of calculations on your calculator. So I'm going to steadily show you more and more tricks and things you can do on your calculator as we go through this stuff. You don't have to become a master of your calculator, but there is something I will be asking you to do when we get a couple problems on. There is something I want you to do on your calculator. So let's see. It's going to be log of 12 parenthesis divided by log of 7. Now you need that parenthesis there. Let me see if I can't zoom in a little bit. You need that second parenthesis there. Without it, it's going to be wrong. So we get 1.27, etc. First things first, let's see if we can't round that to the nearest 10,000th place. So that's the fourth decimal digit. 1, 2, 3, 4. Now, if you're careful, what does this round to? If I'm rounding to this place right here, 2770. So approximately 1.2770. Would it be okay if I wrote it without the 0? No, not if I'm asking you to round it to the 10,000th place. If you're asked to round to 4 decimal digits, there should be something in that digit. Whether or not it's a 0 doesn't matter. It has to be something there. Now, let's see if we can't prove that we got this thing right. What I'm going to do is I'm going to store this variable. So right next to the 1 is the stow key. We're going to store this in x right here. And it's going to look like this. It's going to take your answer and store it in x. There's only one x right here, next to the alpha, right there. All right. I know there is another x. If you want to be picky, there's right above the store key, but no, store it in here. And now let's check it by typing 7 to the x power, because x has our solution in it. So I should get what when I type 7 raised to the x power? Should get 12. Bam. You got 12. So 7 raised, that'd be this key over here. Raised to the x. Raised to the x, are you getting 12? Good, good. Sure. Let me see if I can't do it a different way. Smart view. I think I have something called TI Smart View. There it is. It's starting up. So this will give you a better view of what we're doing. So let me clear this out here. And also clear this out. Yes, clear that out. Thank you. So originally I had log of 12 right parenthesis divided by log of 7. And you can see all the keystrokes that I have underneath here. And let me just take care of two birds in one stone. I'm going to store that. So the store key is next to the 1 in X, which is next to the alpha. Ooh, it should give me an X. It's not. That's because the mode has been adjusted someplace different. Enter. Let me get back there. X. There we go. So I'll store that in X. And then to check it, I'll do 7 raised to the power of X. There you go. 12. All right. Does that help? Okay. Let's try a different one. So kind of building on our success, we'll tackle problem number 32. And what's going to happen as we go through this lecture is that I'm going to get, yes? There you go. Thank you. So what's going to happen as we keep going is that I'm going to get meaner and meaner and meaner. No, I'm kidding. The problems are going to get more challenging. All right. So let's take a look at problem number 32. Kind of the same thing going on here that we had with the previous one. You've got a variable in the exponent. And when you do have something like this, that's an exponential equation. You're probably going to have to deal with logs to solve that. So if I take the log on both sides, log of 5 to the x plus 1 equals a log of 3. By the way, what base logarithm am I using here? 10. Okay, I'm using 10. We'll experiment with other bases later on. But for now, this term comes out in front. But if you notice, I put parentheses around that. And that's kind of important. X plus 1. I would suggest it. That's because sometimes you're going to need to distribute this in order to solve. And you have to realize that it's log of 5 times x plus 1. If you just wrote x plus, 1 log of 5 or just log of 5, that would be much different than what I have here. X plus 1. Here I'm just adding x to this, whereas this is multiplying the quantity x plus 1. So they're pretty different. But kind of like the last one, I want to solve for x. The first thing that I'll do here is I'll get rid of the log of 5 from the left-hand side by dividing both sides by the log of 5. So let's just do this. I'll divide by log of 5 on both sides. Log of 5. Why does that help? What advantage do I get there? Yeah, these cancel, right? So you're just left with x plus 1 equals a log of 3 divided by the log of 5. And so great. We're almost done, though. We're not quite done. Perfect. Thank you. Subtract 1 from both sides. So that's going to be x equals the log of 3 divided by the log of 5 minus 1. And again, we're going to see if we can't play with that, get a nice decimal value, and then check it. So let's do that here. So I want the log of 3 divided by the log of 5 minus 1. Now, I'm going to keep on showing you more and more little tricks here. One trick that I want to show you is, let's see, let's clear this out. Yes, clear this out. One trick that I want to show you is how you can do fractions on the graphing calculator. If you hit the alpha key, then the y equals key, that first option there allows you to do fractions. So you can either type the number 1 or press enter. And wow, cool, now I can do a fraction, just the way we write it on our paper. So I want the log of 3, and just out of habit, I'm going to close my parentheses there. Log of 3, use the down arrow, and then log of 5. And then the right arrow will exit that fraction. What else do I need here? Minus 1. Good. And then while I got it here, let's hit the store key. Store that in X. So it's going to do two things for me. One, it's going to give me the value. And two, it's going to let me check my work. So is everyone able to get about 3.174? Okay. All right, so our answer is about 3.174, but I want to check it. Negative 0.3174, I should say. How would I check it? What do you think I can do to double check my work here? Yeah, 5 to the x plus 1 power. So with that value of x, I can just type in my equation. In fact, since I've got it on Smart View, let me check it out over there. I should be able to do 5 raised to the x plus 1. And what should I get when I press the enter key? 3. Nailed it. Nice. So, how are we looking on those first two? Doing okay? All right. You know, it depends on what I ask. I could ask you just to solve it. And if I just ask you to solve it, then this would be your final answer. That's the solution. That's an exact solution. That's great. But if I ask for a decimal answer, I'll probably tell you, round it to the nearest 10,000th place or something like that. Then I'd be looking for this. Chances are I'm not going to be looking for decimal answers for most of them. I mean, that would become really cumbersome and tedious if I say, all right, find a decimal value. But I could. You should be ready to give me some decimal values. It's something that I'm trying to practice with you here. Yes?
Quick question. So you did log 3 minus 1. What you did store x to get that number. How did you get the 3 except 4? Like on the calculator, that's what I need.
Okay, so there's a couple ways you can do that. Let me clear out this whole screen, and then I'll go back and show you a different way to do it. And this is going to be a little bit more generic. It's not going to rely on this little fraction trick that we got here. So if you've got an older calculator or something that doesn't do the math print like I've got here, then you'll do it this way.
So I got the log 3 divided by log 5 minus 1. I got the negative 0.317.
Oh, you got that?
Yeah.
Oh, okay. Oh, so to check your answer, well, tell you what. Let me finish what I was explaining here. So it's going to be log of 3 divided by log of 5. And what you got to be careful of is you got to close the parenthesis on this. Minus 1 stored in x. And bam. That gives you your value, and then you can check it by typing in the left-hand side of the equation. 5 raised to the x plus 1. Now, if you don't have a calculator that gives you the exponents like I do here, the nice fancy ones, if it gives you a little caret like this right here, then what you would need to do is put parentheses around your x plus 1. So x plus 1, and then press enter, and it should give you 3, just like before.
Okay, that's what it was. It was
the parentheses.
X and then the parentheses.
Okay.
Thank you.
Sure. Let's try problem number 34. And like I said, I'm going to get a little bit meaner. The problems are getting more challenging. So let's take a look at problem 34. So I've got 6 to the x equals 7 to the x minus 4. Okay. Well, where are we going to start? What have we done for the last 2 problems to get started on these things? Good. Take the log, and taking the log is what allows the exponent to come out in front. So please don't just put the exponent out in front now, because you can't. You have to take the logs first. That's what gets all this done for us. So the log of 6 to the x equals the log of 7 to the x minus 4. And then what? All right. These two come out in front. Now, in particular, on the left-hand side, we've got to be careful. I hope that you don't write this. Perfect. You need parentheses around that x minus 4. Because here, it really makes a difference. Because here, this is just negative 4 times log of 7. You want the whole quantity multiplying that log of 7. Now, there's 2 tricks on this problem. 2 little spots where you have to do a certain step in order to continue and get this problem right. So the first one is right here. So let's give that a little star here. Let's see. I'll do it with this one. So there's our first trick, and that is our first trick is we're going to distribute this term to both of these inside. So it's going to be x log of 6 equals x log of 7 minus 4 log of 7. Now, why did I have to do that? Well, in this one, I've got x's on both sides. And in order to solve, I need to get the x on one side. So, whereas in problem 32, I only had one x, I could just divide by log 5 on both sides, and I had x almost by itself. I can't do that here. I can't just divide by log of 7 and have the x on one side. So, it's a great question. I hope you understand my answer. All right, thank you. Now, so that's one thing I got to do. But if you notice, the x is on both sides. In order to try and get this together, I need the x on one side. Yeah, so we can either move this over here or this over here. Doesn't matter. Now, I'm going to be consistent with what I've done for my morning classes, and that is, I suggested that we do 2 things. I'm going to move this over here because when something changes sides, what else changes? It's signs, right? And the nice thing is that when it changes signs, it's going to become a positive. So I like that. Now, the other thing that I got to do is get the x's on one side, and that'll be this side. So I'm going to move this term over to here. And again, when it changes sides, it changes signs. Good. Make me look good because this is going on YouTube, right? Okay. Thank you. All right. So, see if you can't write down the equation that I get when we make these changes. These 2 terms are going to change sides. This one didn't move, so I'll just write that down. X log of 7. What's going to be on the left-hand side here? 4 log of 7. Good. X log of 6. Excellent.
So the 7 with the log does not change the size?
No, it stayed here, and I want it here because, both of these or both of these down here now have an x, right? That's what we're looking for, is to get the x by itself. Well, we will get to dividing, but there's something we got to do first, and it's the second little trick in this problem. So right here, kind of a second little asterisk. Well, it's a good question. Are they like terms? Not really. Well, I mean, I guess it depends on how you look at it, but what we're going to do here is we're going to factor out the greatest common factor. The GCF here is what? X. Yes, exactly. Well, the base, what's understood to be the base? 10. The base is log 10. I just can't subtract 7 minus 6 and get a log of 1 or anything like that. There is something we can do, but I'll get down there in a little bit. For now, can you understand why I factored out the x? It's because now I've got the x by itself, almost. Because if I distribute, then this multiplies this minus this times this. It multiplies both of them. So I'm just factoring out the GCF. I could have put the x here and factored it out in front. I just factored it out in back just because I like it. It looks better. Yes, good question. Can we divide now? Yeah. So x is being multiplied by something. To undo a multiplication, we use division. So it's going to be 4 log of 7 divided by log of 7 minus log of 6 equals x. Wow. No, because because you're going to divide both sides by this. So, in order to... Okay, you're good? All right. Now here's the challenge. Can you calculate this on a calculator? Because this is kind of like the level that I give you. I give you on certain tests, I'll say, okay, the solution to this equation is this. Calculate its value. So I'm not asking you to solve it. I'm asking you to calculate that value on your calculator. It's not necessarily easy. So typically speaking, people give me 2 different answers. I think one of them is like 3.3 and another one's 3.22. Okay, 3.22. And another one is like maybe 50 something, 50.4. 50.493. Okay. So since today's voting day, I hope you guys all got out and supported your favorite issues and stuff like that. Let's vote on it. Calculate it out. How many people are getting 3.22? So 1, 2, 3, 4. All right. How about 50.49? 1, 2, 3, 4, 5, 6. There we go. Cool. And how many don't know what to do? All right. There's got to be a few hands up there because I don't think everyone voted. But let's take a look at how to do this on your calculator. The big trick here is that you're going to need parentheses in the denominator, or you need to do something a little bit careful in the denominator. So let's do this. 4 log of 7. 4 log of 7 divided by, and then I want parentheses, log of 7, another parenthesis to close off the log, minus log of 6, another parenthesis there, and then, how come one more parenthesis? Close off the denominator. So, bam. So 50.49, give yourself a hand. Yay, good job. Now, one way you can make this a little easier on yourself would be if you use that little fraction trick that I showed you earlier. So let me do that. I don't know if it shows up easier when I do things here. So let me clear that. Clear this. Yes, I wish it wouldn't ask me if I want to clear there. Okay. If you hit the alpha key, then the y equals key. Press enter to get the first option. Now, because of the way it's drawing your fraction, you don't necessarily need to use parentheses so much in the denominator. So it's going to be 4 log of 7. And then use the down arrow in the denominator. It's going to be log of 7. Right parenthesis closes off the log minus log of 6. You could get away without a parenthesis there, but let's not. I'm going to hit the store key and store that in X. So 50.493, etc. Yes, the way to do the division trick on the old calculator is to update your operating system so that you can do the division trick like we do. Oh yeah. Yours. The 83 doesn't do it, and the 84s can do it if you update them, if you update their operating system. Or you can borrow mine, just saying. All right. Oh, yeah, that's right. Now, the only reason I hit the store key is because I want to show you that we can check our answer. So that's nice. And it's not too late. If you hit the store key now, store in X, you should be able to get what I'm going to show you right here. And that is, let's check it. If this is right, if we got this right, then I should be able to do 6 to the x and get a number. And then if I did 7 to the x minus 4, I should be able to get the same number. So let's see if that happens, okay? So for me, it would be 6 raised to the x. Now this is going to be a big number in scientific notation. That's okay. I just want to make sure I get the same thing when I do 7 to the x minus 4. Do I get the same big number? And they look pretty identical to me. So pretty confident that we got that one right. Not sure. All right. You're probably missing some parentheses someplace. All right. But tell you what, just like a good old, Ronco type commercial. But wait, there's more. So let's take a look at this one more way. I'd have to take a look at it particularly, but I'll tell you what, we got one more thing that we can try to help you get the right thing. So let's use some of our properties of logs. If I wanted to, I could bring that 4 up into the exponent, right? It'd be 7 to the 4th power, the log of 7 to the 4th power. Well, that's just going to become log 7 to the 4th power is 2,401. Okay. How about the denominator? In the denominator, we can use our quotient rule. The difference of logs can be written as the log of the quotient. Log of 7 over 6. So this should give me an equivalent expression. Let's see that it does. So log of 2,401 divided by log of 7 over 6. Bam. Same thing. Did you get it right the second time? Because people had trouble putting in their calculators this way. And it's also more practice with your rules for logarithms. No. This is going back to your properties of logs. Remember our quotient rule. We had log of a over b becomes the log of a minus the log of b. So that's the quotient rule. Now, last week we were using it mostly this way, right? But you could also use it this way. So that when you have the difference of logs, it's the log of the quotient. And that's what we did here. We just treated this, got the log of the quotient. So, lots of different ways to look at that one. But I think we beat that one to death. So, all right. Anything else on problem 34 before I move on to problem 36? Yes. So the final answer was about 50.4937. Your turn to try one. And it's going to be very similar to that one. It's problem number 36. 8 to the 3x equals 9 to the x plus 1. How would you start one like this? What are you going to do first? Take the log. Good. So it should start with log of 8 to the 3x equals a log of 9 to the x plus 1. And then you start using your power rules. That term is going to come out in front as well as that. So, see what you can do with this one? If you did it right, you should get something a little bit more than 0.5.
with a slightly different expression because I'm going to move things in different sides.
Okay.
But we'll still get the same answer. Yours will just be in the opposite order of mine.
Right. Okay.
Okay, good. So what I would do here is I would move this term. So I would just move this over here. That would give you 3x log of 8 minus x log of 9. So you're shipping this whole term, this is off the whole terms. So x log of 9, 1 log of
Which one? That's what I don't know what to do.
Here's my log of 9. I can write it for you. Well, no, when you multiply by 1, right? It's always something 1. Still.
Okay, you do x log 9.
So that's going to give you your log of 9 here. Then the trick is to factor
And then you
out
keep that the same.
x. So x, both of these changeable out. That's going to leave behind 3 log of 8 minus log of 9. What's the last step? Hey, good.
So you subtract
You need to increase the denominator. What I would suggest is go back here.
the whole x minus u.
Okay. So the second insert is there. Insert here. Let's scroll down. Okay. Is that what I want? Negative? I'm not sure. Find the front of the other one. Now, the other way to do this is the second here. And now you don't need second blank or alpha blankets. Now you don't need parentheses as much because you're not dividing by something with a 9 in front of it.
Yours would be 2x.
Okay.
Okay. So the 3x comes out in front. It gives me 3x log of 8 equals x plus 1 log of 9. And kind of like last time, I'm going to remind you that there's two places that you need a little bit of finesse. This is the first one right here. And the trick here is to do what? Distribute. We're going to distribute that log of 9 to both of these terms inside. So that's going to distribute itself here and here. That gives me 3x log of 8 equals x log of 9 plus, well, 1 times anything is still itself, right? So it's just going to be plus log of 9. I've got x on both sides. I've got x here and I've got x here. It'd be nice if I had x on one side. So what looks easiest to me would be to simply move this whole term to the left-hand side, right? That way I'll have x just on that one side. Okay? When it changes sides, it changes signs. Well done. So 3x log of 8 minus x log of 9 equals a log of 9. Great. Now comes the second little trick here. And that second little trick right here is to do what? What are we going to do to... Yeah, factor out the x. Good. X is a GCF. So that's going to leave behind 3 log of 8 minus log of 9 times x equals a log of 9. Yay. Last but not least, x is being multiplied by something. To get rid of that multiplication, what do? Divide. So I'll actually take the time to show it here. We're going to divide both sides by 3 log of 8 minus log of 9. 3 log of 8 minus log of 9. Well, on the left-hand side, everything cancels except the x. On the right-hand side, no, it doesn't cancel. No, yeah, well said, Jake, thanks. It's connected here. 3 log of 8 minus log of 9. They're connected, so I can't cancel into that. We're just kind of stuck with it. You know, some people will have done it the other way. That is, they'll move this over here and then move this over here. Well, an equivalent expression that I've seen some people get would be minus log of 9 over log of 9 minus 3 log of 8. And I say that's an equivalent expression because it's opposite of this in the numerator, but it's also opposite in the denominator. And so if you have a negative divided by a negative, they cancel each other out. So that'd be a different way to write the same solution. In fact, I think I warned a couple of you that, okay, when I do mine, it's going to look a little different than yours, but you get the same answer numerically. So that'd be a different possibility. When I grade these things, it takes me a while to look through and see, well, is what they got, is what she has equivalent to mine? And, you know, oftentimes they are, so even if I write my answer different, I'll give you credit for it. Okay. All right. Enough with the hard ones for a little bit. All right. That's as hard as they're going to get. Let's do an easier one, but we're going to switch up the way we do our easier work here with problem number 38. Now, for the first few problems that we've been working on here, we've done log base 10 on both sides. But we don't have to do just base 10, right? In fact, as we started this, I think I took pains to say that you could take log of any base. Now, there's two bases that are directly on the face of our calculator, log base 10 and log base e. What if we experiment with a different base? What base might we try? ln. Take log base e. Now, even though it's log base e or ln, a lot of times they're going to write ln. I'm going to write it as log base e of e to the 3.3x equals log base e of 9.1. So I'm taking log base e on both sides. You're correct. This is really ln. But there's a reason that I wrote it as log base e of e to the 3.3x as opposed to ln of all that. Yes. Nice. Remember our properties last week. When this base and this exponent, or the base of this exponent, match, then these cancel. So what are we left with? There you go. 3.3x equals 9.1. Can someone solve for me here? Divide by 3.3, right? Wow. X equals ln of 9.1 divided by 3.3. Hey. Wow. Compared to the last one.
That was easy.
Yeah. Nice. That was a lot more friendly than our previous ones because we chose to take log of the same base. So, nice on that one. Let's do that again. Let's try it with problem number 40. E to the negative 0.7x equals 6.2. Okay. Play the same game as we did last time. And I'll I'll let you work on that for a moment. Bella, how should I start off? Perfect. Perfect. Bogdan, do I get any simplification here?
Yeah, the e allows for left with -0.7.
And let's call that ln of 2 on the right-hand side. So x equals ln of 6.2 divided by -0.7. Let's actually get a value for that on our calculators. And I'm not going to try and do anything fancy here. I just want to get a nice value. So let's see. ln of 6.2 divided by -0.7. So about here. And if I wanted to check it, I could. Let me store that in x. And then do e to the -0.7x. And if I did it right, I should get 6.2. Yay. Nice. So approximately speaking, you should get -2.6065. Is everyone able to get that number, or approximately speaking? Okay. I did e to the -0.7x. It depends on your calculator. Not on that one. Not on the 84s. You don't need to. Some of the older ones you might need to. Now this is a cool idea. Taking the log of that base. It's made our life a little bit simpler. And let's see if we can't make it simpler with a problem like number 22. 3 to the x plus 1 equals 27. Well, if you're going to tackle this one, what base logarithm would it make sense to use? 3, yeah. Let's take the log base 3 on both sides. Log base 3 of 3 to the x plus 1 equals a log base 3 of 27. So it's nice. We're using base 3. See if you can't simplify this equation. I'll give you a little heads up. It simplifies very nicely. Really nicely. Now, you might not necessarily be a whiz at doing some of these calculations in your head. That's okay. But you should at least be able to simplify the left-hand side. So, Alexa, what's the left-hand side going to be when we simplify it? Sure, x plus 1. Now, how about the right-hand side? What power of 3 gives you 27? 3. And like I said, if you're not good at that, remember, your calculator can bail you out. If you go to the math key, then up, log base A, I'll type in the 3, arrow over to the argument, type in a 27, and bam. Oh yeah, that makes sense. 3 to the third power is 27. Wow. I like this one. What does x equal? Yay. X equals 2. Wow. Somebody give my button some love.
That was easy.
Thank you. X equals 2. Nice. And this is working because of those properties of logs that we went through last week. Taking the log of the base. Boy, that's pretty nice. That these cancel out very nicely. Okay. Let's try a couple more like that. Let's try problem number 24. Looks like this. Gotta zoom out a little bit. 8 to the negative 2x plus 1 equals 1 over 64. Taylor, maybe you can start us on this one. What should we do to both sides to get rolling? Something with 8. Okay. Jataya, can you, Crystal? Yeah, we'll take the log base 8 on both sides. Log base 8 of 8 to the negative 2x plus 1 equals log base 8 of 1 over 64. Okay, that's a good start. Then what? All right, on the left-hand side, you get negative 2x plus 1. On the right-hand side, see if you can't use your calculator or maybe just think through to figure out what log base 8 of 1 over 64 would be. Yeah, a couple people are getting that. You can do that off your calculator pretty easily. So math, and then up here, 8 and 1 divided by 64. Oh, negative 2. Yeah, that makes sense. 8 to the negative 2 would be 1 over 8 squared. So, nice. Subtract 1. And then x equals negative 3 over negative 2. I'd probably appreciate if you simplified that to 3 over 2. Yeah. Leaving it as negative 3 over negative 2 puts me in a hard spot. Wouldn't want to be there. But hopefully you'll just take care of the business with the negatives there. Nice. And that's it. I'm done on that one. So it's a great idea to use log of this base on both sides. It makes these problems a lot easier. Now, can you always do that? Not easily, not really. I mean, take a look over here. You can take log base 8 on both sides, but you know what? You're not going to get that simplification here, right? Because it's not going to be, well, you're not going to have log base 8 of 8 canceling. You have log base 8 of 9 something. So it won't give you that nice cancellation. So does it work everywhere? No. Yeah, it works well when just one of the sides has an x. Yeah. If, you know, I would suggest, as long as you don't have x on both sides, like problem 36 or problem 34. So these two, well, I mean, you could do something like that, but it's not really going to help out too much, or as much as it did in some of these other ones. If you have x just on one side, then it's a good idea for sure. Okay. Yes. So, for instance, let's go back to our very first one. It was problem number 30, I believe, right? 7 to the x equals 12. Looking back at this one, what's a different way we can do it? Take log base 7 on both sides. Yay. So if you did that, log base 7 of 7 to the x equals log base 7 of 12. Okay. Jake, can you simplify the left-hand side?
X.
Yeah, it's just going to be x equals log base 7 of 12. And if you calculate this, let's see, on your calculator, log base 7 of 12. Now, if I remember right, earlier we got like 1.27 something. Wow, you're getting the same answer. Cool. What if you didn't have this feature on your calculator and you had to use the change of base formula? The change of base formula said that'd be log of this divided by log of the base. But guess what? That's the answer we got when we did this problem originally. Log of 12 divided by log of 7. Cool. Nice.
So on the test, either way it will be fine?
Yeah, either way it'd be fine. Now, just make sure that you can give me a numerical answer if I ask for one. Like I said, I can't and won't be asking for a numerical answer on every problem. It's just not what I do. Just a quick aside here. Somebody in my morning class says, well, can't we still do it with base 10? Let's take a look at this problem with base 10. And if you're afraid of heights, then close your eyes, because this one gets nasty. I didn't like, even for myself, I'm like, oh, God, this looked awful. But here's what it looks like if you did it with base 10 on both sides. So you take log on both sides. Now, I don't write anything when I have to write log base 10, so we're okay there. Let's see, the exponent comes out in front. There's no nice simplification here because log base 10 of 1/64th, I don't know, -1 something. This comes out. Again, I don't get any nice cancellation, so what do you have to do? Well, you have to distribute this to both terms. Oh, actually, no, I guess I did it a different way. I divided both sides by log of 8, which gives me this lovely expression. You got your eyes still open still? I'm impressed. Good job. Well, then I'll subtract 1 from both sides, so then I get this ugly expression. And then I can divide by -2 for all of that. Wow. Put that in your calculator and smoke it. I mean, it's just an annoyingly large expression. You know, it worked, but I'll be honest, it took me like 3 tries to make this work on my calculator and give me, 3 halves for the answer. It was a pain. So, yeah, I think this is a good little trick here, taking the log of that base. Leave the, if I don't ask you for a numerical answer, if you left me that, that's not wrong. That's the right answer. So there's nothing wrong with that. Now, if I ask you to go farther and give me a numerical answer, then you have to be able to do that. But, no, I mean, and I've shown you the button to do that on your graphing calculator. Yes?
Question about my calculator. Does this one, do you know off the top of your head, like the base? Like, I don't know how to find it.
It might not be on your calculator. If you look at your calculator, and this is not just for you, it's for everyone with a TI calculator. If you do second and then
The y equals?
no. Just follow me here. Second and then plus, it should give you a memory. It should give you so how about second and plus? There you go. It should give you a menu like this. And if you press enter to get about, you'll see the operating system. So you want to bring yours up here real quick? All right. So the operating system that you need for your older calculators is 2.53 or 2.54 MP. And this one, it's hard to get it to show there. There you go. The operating system here is 2.22, so it's not as up to date as it could be. If you go to education.ti.com or call 800 TI Cares, they can help you figure out how to update it. And yeah, you need to have it updated to yours. The 83 won't update. Sorry, but the 84s will update to 2.55 MP, which stands for math print. Okay, good questions. Let's keep going. You break down and use one, huh? Let's do one last one like this. Problem number 26. Three to the x squared minus 3x equals 81. Okay. Marzena, how would we start on this one? Log base 3 of 3 to the x squared minus 3x. Perfect. Perfect. Now, Zarima, the left-hand side is going to simplify for us, right? And Chris, get ready with the right-hand side. Good. And are you going to do the right-hand side for Chris? All right, Chris, you're stealing your thunder, but I don't see you fighting her for position on that one. So, unless you can outthink her on that one. Can you think faster than she can race with her calculator? What power of 3 gives you 81? 4. All right. Cool. You shouldn't be square rooting 7 here. Okay. Yeah. Now, this is wonderful. You guys don't realize how good you got it. This is the best of both worlds. Not only do we get to solve logarithmic equations, as an added bonus, you get to solve a quadratic equation in the same problem. How cool is that? All right. What are we going to do here? Good. I'll subtract 4 from both sides. X squared minus 3x minus 4 equals 0. Do I need to pull out the quadratic formula on this one, or is there something else I can do? Yeah, let's do that factor thing, all right? Quadratic formula would be like squirrel hunting with a bazooka. All right, so x and a minus. 4 and 1, which one's positive, which one's negative? All right, so the larger one has to be negative because it matches that sign. What are my two possible answers from this? 4 and negative 1. So you get two answers out of that one. Actually, both of them should work. So, what's that? Well, in our exponential equations, I mean, it's not a bad idea to plug in and see if they work. Negative 1 squared is 1. What's negative 3 times negative 1? Plus 3. So 1 plus 3 is 4. 3 to the 4th power? Oh, okay, yeah, that's 81. What about the 4? 4 squared is 16. 16 minus 12 is 4. 3 to the 4th power? 81. So they both work. Now, it's nice to check them. In these equations, it's optional. When we come back from our break after the next problem, when we solve logarithmic equations, you have to check them. It's not an option anymore. It's kind of like our work with, rational equations, that you had to check and make sure you didn't have a 0 in the denominator, that kind of thing. Okay. Let's do one last one kind of like this. And that's going to be problem number 66. And I like this one. It's 8 to a power to another power. 8 to the x squared equals 11. Well, this is just another exponential equation problem. She's shaking her head like, no, this one looks worse. All right, let's just make baby steps at it. Jataya, let's start by taking logs on both sides. What base would you suggest? Log base 8 on both sides? Okay, let's try that. Log base 8. I was being kind. Just nod like you meant it. I would do 8, yes. Because 8 gives us some simplification here, right? Sam, what's going to happen when we take log base 8 on both sides here? Can you simplify that for me? Good. X squared equals, let's just leave it as log base 8 of 11. Okay. Take the square root on both sides. Excellent. So I'll take the square root here, square root here, log base 8 of 11. This doesn't simplify, but there is a little something missing that is concerning to me. Can anyone figure out what that little thing is that's missing? Ah, there you go. Plus or minus. Yeah, I know, he's so picky. Sorry about that. Yeah, you do need the plus or minus, but both of these will work. And that's it. That's your solution. If you needed to calculate it, you could. If you didn't have a fancy calculator, you could do the change of base formula. It's going to be the log of this divided by the log of the base. So that's how you might actually see the answer in some books or in Newton or something like that. They might not use log base 8. But I'll tell you what, if WebAssign or Newton didn't allow you to use log base 8 in an answer, complain. If you don't get any satisfaction, let me know. I will get satisfaction. Because you should be able to use log base 8 here. There's nothing wrong with that. Yes?
We're not allowed to have square root in the denominator? Would that be wrong?
I'm not going to ask people to rationalize that. It'd get really ugly if we rationalize that. So, yeah, we'll ignore the no radicals in the denominator thing. But thank you. Well, why do we have to use a plus or minus? Can anyone suggest a reason? Yeah, because we're taking the square root on both sides. That's why you needed it there. So, okay. Yes. Yeah. So, okay. Let's take a break here. We'll come back and we'll finish up logarithmic equations.